So, when we look at the Woodward reaction, again the first step is very similar to the previous one only. We end up with a cyclic iodinium ion, and the second step is also very similar, that is the anion of the corresponding silver salt adds to the nucleophilic substitution to the iodinium ion. So, this is also very similar to the Prevost mechanism. In the third step, what happens, the carbonyl oxygen internally attacks the carbon bearing the iodine with the concomitant loss of the iodine, leading to the acetoxonium ion. So, in the previous case we have the benzoxonium ion, here we have a acetoxonium ion intermediate. So, up to here we follow the same type of mechanism, both the Prevost mechanism and Woodward mechanism follows the same procedure, but the difference happens here because in the this intermediate is being attacked by the water nucleophile. So, this is one of the major change which happens in the Woodward reaction, which is not happening in the Prevost mechanism. So, the water now attacks the partially positive carbon atom of the acetoxonium ion intermediate, which gives the cyclic orthoacetate, and finally, the water molecule opens up the cyclic orthoacetate acetate intermediate to give the monoacylated diol product, and in this particular case we end up with a cis diol. Let us look at the reaction mechanism in detail. So, as we mentioned, similar to the Prevost mechanism, the first step is the addition of iodine atom. So, this adds to the alkene to give the cyclic iodinium intermediate, and this iodinium intermediate is attacked by the carboxylate anion. In this particular case we have the acetate anion. So, this addition is again a trans addition, and this opens up to give the this particular product, and here it is the first trans addition, and as similar to the previous case, this particular carboxyl oxygen internally attacks the carbon having the iodine, and the iodine is lost, we end up with the acetoxonium intermediate. So, up to here the reaction proceeds exactly similar to the Prevost mechanism, but the major difference in the Prevost mechanism and Woodward reaction mechanism is the addition of water molecule. So, this is the most crucial thing which does not take place in the Prevost mechanism, but in the case of Woodward reaction mechanism we actually use water in the first step also. So, this water molecule adds to the carbocation. So, this acetoxonium carbocation is being attacked by the nucleophilic water molecule, which leads to the cyclic system as shown here. This is the cyclic orthoester, that means this carbon has 3 oxygen atom attached to it. So, this is a cyclic orthoester intermediate that is formed, and this cyclic orthoester on opening gives the product as shown here. So, when it opens up, one of the hydroxy unit is from the same side, and the corresponding ester is also present in the same side. If you look at here, this corresponding ester and the hydroxy unit both are present on the same side of the double bond. So, that is the reason this particular reaction leads to a cis diol as the final product. This particular acetate is cleaved in the last step using a base, leading to the formation of the cis diol. So, that is the reason the major difference between Prevost mechanism and Woodward modification is the addition of water in the first step, and also the salt, silver salt what we use in these two reactions are quite different. In the previous case we have the benzoate anion, in this particular case we have a acetate anion. In the case of benzoate anion, actually the benzoxonium ion is actually stabilized very much by the benzene or the aromatic system. That is the reason the second step addition of the carboxylate takes place from the opposite side. But in the case of a Woodward reaction, this particular water molecule is the nucleophile which attacks the acetoxonium ion from the same side. So, that is the reason this reaction, the addition of water actually changes the course of the reaction, and we end up with the cis diol formation.